So, here's a question for you. How do you build a single, verifiable record of truth that can live across totally different blockchain worlds? Like the whole Ethereum ecosystem and the super fast lane that is Solana. It's a huge challenge, right? Well, today we're going to tear down exactly how that's possible by looking at the anatomy of WowSW3, a platform built to do just that. Here's what we've got on tap. We'll kick things off with the big picture, the multi-chain protocol itself. Then, we're going to follow a single piece of data on its journey, all the way from a click in a dashboard to an immutable record. We'll dig into the two very different ways this works for EVM chains and for Solana, cover the absolutely critical security layers, and then we'll wrap up by seeing how it all fits together and what it means for the future. All right, first things first. How does a system like this speak multiple blockchain languages so fluently? Well, it all comes down to a core design choice to be interoperable from the ground up. Now, for the entire EVM universe, the secret sauce is something they call the Quantum Echo Protocol, or QEP. The best way to think about it is like a high-tech, on-chain notary. Its one and only job is to take a very specific piece of data, an echo, as they call it, and stamp it forever onto the blockchain. And crucially, this whole process is kicked off by a secure backend engine. And listen, this isn't just an idea on a whiteboard. The QEP is live right now, active on huge EVM networks like Polygon, BSC, and Avalanche. You can see each one has its own unique deployed contract. And check it out, Solana is already baked in at the backend level too. This creates one unified system that spans all four of these major networks. Okay, so we know the protocol exists, but let's follow the breadcrumbs. How does a simple request inside a web dashboard end up as a permanent, unchangeable record on a public blockchain? It's basically a four-step dance. It all starts with the user putting some info into the dashboard. Then, the front end gets to work, orchestrating everything that needs to happen. That orchestration triggers a secure call to the backend engine, and only that, is what finally executes the write to the blockchain. Now, the real star of the show on the front end is this one file, orchestrator.ts. Think of it like the conductor of an orchestra. It looks at what the user wants, figures out which analysis tools or modules it needs to use, and then directs the entire flow of the process. This all happens before the backend even gets a whiff of what's going on. Okay, let's zoom in on the EVM side of things. How does that final step, the on-chain write, actually go down using this Quantum Echo protocol? The whole thing is designed with a security-first mindset. The front-end app can't just write to the blockchain whenever it wants. No way. Instead, after the orchestrator does its thing, a request gets sent over to the WXO core engine. This backend is the sole gatekeeper. It's the only thing in the entire system that has the keys to call the protected API endpoint that triggers an on-chain transaction. So, what is this echo that actually gets written? Well, it's not the full multi-page report. That would be crazy expensive and super inefficient. Instead, it's a cryptographic hash. Think of it as a unique digital fingerprint of the entire report. This tiny, efficient piece of data is all you need to serve as absolute proof that the full report, with all its specific details, existed at that very moment in time. All right, let's totally switch gears and jump over to Solana. Its architecture is a completely different animal from EVM, which means you need a whole new playbook for storing data on-chain. And this really gets to the heart of the different philosophies. With EVM, the QEP uses one giant smart contract. It's like a public ledger where everyone's data lives, and you control access using roles and permissions. Solana, using the Anchor framework, does the complete opposite. For every single analysis score, it creates a unique, separate on-chain account, a program-derived address, or PDA. This means every piece of data gets its very own private, secure box, totally isolated from everything else. This is all made possible through a set of instructions built into the Solana program. Functions like register score with CK are at the very core of it all. But what's really important to get is that before you can even think about calling these, the entire program, which is written in Rust, has to be compiled and deployed to the network. That initial setup is what makes all this on-chain magic possible. So for any devs watching, here's the really cool part, how these unique accounts get made. Solana uses what's called a deterministic seed system. It's like a recipe. You combine known text strings like score and public with dynamic info like the target's address, and boom, it generates a predictable and totally unique on-chain address for that specific piece of data. This is a massive shift from the EVM world, where you're managing who can access one big contract. Here, every piece of data gets its own calculated address. Of course, all this incredible tech doesn't mean a thing if the system isn't locked down tight and the data isn't permanent. So let's peel back the layers that guarantee every record is safe and sound forever. First up, the EVM smart contracts. They ran a full audit using Slither, which is the gold standard for this stuff. And the result? Zero. That's right, zero critical or high-severity vulnerabilities found. It found a few tiny informational things, but that's basically a clean bill of health. It's a huge vote of confidence in the code. They also hardened security at the database level. See, an early version had a policy that technically allowed public data insertion into a critical table. That was a potential risk, so it was completely removed. Now, the only way to write to the WSEO_registry or WSEO_echoes tables is by using the secure backend-only service role key. That door is slam shut and locked. So here's the full strategy, all working in concert. You got the report hash, our digital fingerprint, stored forever on the blockchain. The full report document itself gets uploaded to IPFS via Pinata, which is a decentralized storage network. This means it's not sitting on one server somewhere. It's spread out and can't just be taken down. And finally, all the metadata that ties these two things together is stored in Superbase. It's a brilliant 3-layer cake of persistence.
You know, when you take a step back and just look at how all these pieces connect, the multi-chain support, the two completely different architectures for EVM and Solana, the layers of security and persistence, it's just an incredibly elegant solution. Wow.
All right, for our last section, let's zoom back out. Let's look at how this powerful engine is actually controlled from the dashboard and what it all means for what's coming next. Remember that orchestrator? Its modular design gives the system amazing flexibility. For instance, the Galaxy Graph module is built to talk directly to external Web3 APIs to get its structured data. But the system can just as easily run a totally different tool, like the backlinks analyzer, which does old-school web scraping. The orchestrator doesn't care. It just seamlessly weaves both results into one unified report.
And this really brings us to the most important point of all. This entire system, this complex, multi-chain, secure, and permanent data registry, it's not a roadmap. It's not a white paper. It is built, deployed, and running today. This is not science fiction, it's reality now.
And that really leaves us with one big final question to chew on. Once you have a proven model for certifying any piece of data, making it permanent and verifiable across multiple decentralized networks, what happens next? What industries, from finance and supply chains to scientific research and even art, are about to be completely transformed by this new power? That is something to think about.